Hey guys, how you doing? This is Coach Scott, Hullabaloo, Nick, and welcome to Purple Wave Chemistry. Let's go more into Unit 6 and talk about phase changes and phase diagrams. I'm going to expect, and you will be able to understand what the phase change is and how do we diagram it, right? So, yeah, you should be able to read these things by the time we're done. So, what's a phase change? This is when we physically rearrange the molecules. Okay, these substances can change the state or their phases due to as a result of changes in the external conditions like pressure and temperature. Right. So if you got a solid, it can melt. It can melt into a liquid, and then this liquid adding more energy, it can increase the pressure or the temperature, then it can vaporize or boil or evaporate into a gas. You start removing energy, all right, then this gas can condense down to a liquid. Again, remove more energy, and this liquid will fuse or freeze into a solid. So, this temperature and pressure at which a substance is going to change phases depends upon the intermolecular forces, the IMFs, holding the substance together. So at standard temperature and pressure, carbon dioxide will sublimate or go from a solid to a gas at minus 78.5 degrees Celsius. At standard temperature and pressure, water boils, going from a liquid to a vapor at 100 degrees Celsius. So, these energy changes that are associated with the changes of state, if you have a chemical or physical change, then they're usually accompanied by energy changes. So, when energy is released in the form of heat, the process is called the exothermic. So, example, when we make ice cubes from liquid water, we're removing heat, our kinetic energy rather from the liquid. So we make ice cubes, that's an exothermic reaction. When snow is formed in clouds, that's an exothermic reaction. When rainwater condenses, right, that's exothermic. A candle flame, exothermic. When the energy is absorbed by the system, then we have an endothermic change of state, right? So when we melt an ice cube, okay, we're sucking in energy. When we convert frost to water vapor, when we evaporate water, when we bake bread, when we cook an egg, when we melt a solid salt, that is a endothermic change of state. So this is a nice little chart. You may want to draw this out, but I can give you. I'll probably print this for you guys. But when we go from a solid to a gas, we sublime. We go from a gas to a solid, then that's a deposition. All right. When we go from a solid to a liquid, we melt. We go from a liquid to a solid, then we freeze. Right. We go from a liquid to a gas, we vaporize. When we go from a gas to a liquid, we condense. And we're not going to talk too much about plasma, right? But we could go from plasma to a gas, and we're recombining some things. And these are all exothermic processes: recombination, deposition, freezing, condensation. Those are exothermic. Endothermic is the opposite. When we go from a gas to a plasma, that's ionization. It's endothermic. Vaporization is endothermic. Sublimation, endothermic. Melting, endothermic. So a phase diagram is a pressure versus temperature graph that will tell us what state a substance is in at a given temperature and pressure. So this little part right here, all right, this is when it's a solid, depending upon the pressure and or the temperature. This would be the liquid. This would be vapor. This is a triple point, and this is when the substance exists in all three stages. a solid, liquid, and a gas. This is the critical point amongst, when it gets higher than that, then you got some weird stuff there, right? So the critical point represents when pressure and the temperature is at which the liquid and vapor phases, they're indistinguishable. You can't tell the difference. I'll show you some videos about those. So this line right here, this is the solid liquid interface. So the melting point at this depends upon the temperature and pressure. Whenever this line goes right here, right from the pressure side to the temperature side, or right there, that'll tell us when it crosses. That's when the melting point is. Okay. The interface between the this one right here, this is where the sublimation point is, right? So whenever this crosses at that particular point at temperature and pressure, that's when the solid will sublime into a vapor. And of course, this interface right here between the liquid and the vapor stage at this particular temperature and pressure, this would be the evaporation point or the boiling point. So looking at water, all right, notice it's got a very high critical temperature and pressure, 374 atmospheres, 647 Kelvin, right? You can see at 1 atmosphere, all right, and 373 degrees K or 100 C, that is what we call standard temperature and pressure, right? That's when its normal boiling point is. Now, why are these this high critical temperature and high critical pressure? This is because of those strong hydrogen bonds that exist between water molecules. So let's look here. This is water again. Let's look at the slope of the solid liquid line. This would be what we call a negative slope. It leans to the left. This means that when we increase pressure, this will cause the substance to melt. And this is why, because as water freezes, the molecules must move a little further apart to form that crystal structure of the solid because of the hydrogen bonding. So this is, as a result of this, the ice is less dense than liquid water. Let's think about that a little bit. All right, so there's a small minority of other elements and compounds that have the same property as water. Water is pretty unique, okay? So we know that ice floats in a liquid water has a significant impact on us and our environment. And again, we've already talked about this. If ice was more dense than liquid, it would sink. There just wouldn't be life. And why is that? It's because of hydrogen bonding. Pretty cool. Now let's look at carbon dioxide. Notice it's a little higher. What's the slope between the solid and liquid phases? It's a positive slope. Most substances have a positive slope. So this means that there's an increase in pressure will cause the substance to freeze. All right, when pressure goes up, all right, it's going to freeze. Now let's carbon dioxide. Now, it cannot be a liquid when it's below 5.1 atmospheres, which is a little bit of pressure, right? But so that means that carbon dioxide will sublime, go from a solid to a gas at normal pressures. All right, guys, so those are phase diagrams. We're going to do a lot of work with that. We're going to do some labs with this, so it's going to be pretty cool. So and hopefully we'll be able to see the triple point of water. So anyway, so guys, this is Coach Scott saying, Hullabaloo, connect, and have a great day. Bye, guys.